I was looking for a definition that would
that would
state
not put, that would put
No.
vertical not being
No.
perpendicular to horizontal at some point.
That's not the point.
Sorry, did I say it the wrong way around?
references.
Horizontal not being perpendicular to vertical.
But I never said that.
At another
so please
point.
don't put words in my mouth. I was basically looking for references to local vertical and local horizontal. And I've
local.
actually found one. Even not one. I've actually found some, but it's basically in the context of astronomy and stuff like that. So not exactly the context I was looking for.
Doesn't help you, does it?
Anyway,
would that be zenith then? Is that what what they're using when they say vertical?
When you're local
zenith is basically a point, right?
Your zenith is a point above your head and with an nadir at your feet, right?
Yeah.
Which would be local to you wherever you are.
Yeah.
Obviously.
Yes.
Yeah. But not necessarily vertical, right?
But the vertical direction is also local. I mean.
Yeah.
Okay.
Well, the vertical is still there. I'll give you that. Yeah.
But the point is here that the vertical may or may not be local. So if you have...
Who says that?
A priori. So let's say that we don't know...
Who says that?
That
No.
sounds like a QE thing, that a priori. It means it's just stated, right?
Yeah.
Yeah.
So what I mean is...
So nobody stated it, or nobody that you know of stated it.
What I'm saying is, let's assume for a moment that we know exactly nothing about the shape of the Earth.
Don't you normally have to put a load of stuff together and then say a priori? Right? I don't think you're allowed to just state a... Do you know what that means? Should we...
Yeah, basically
it means let me just state this without giving any evidence. Is it?
It basically says it basically means literally something like before or something like that. So basically
it literally means before or something like that.
Yeah, from Latin anyway.
It literally means before or something like that.
Here we go. It's deductive reasoning, because we're quite good at logic, right, around here, right? So deductive, you know what that means, right?
Yes, I know what that means.
It means relating to or derived by reason from self-evident propositions. Right?
Okay.
So, where did you give us these self-evident propositions, or did you just state a priori and think you could get away with it?
Okay, let's go back, because we are going...
I think you do need to go back.
Yeah, we need to take a few steps back. And
yes, we're with you.
Sorry?
We're with you on your steps backwards that you need to take.
Okay.
We are with you.
Perfect. So let's assume we know nothing about the shape of the Earth. Nothing at all. Right? We have no idea if it's curved, if it's flat.
Completely with you, mate, because that's how it is, right? That's exactly how you are, right? Yeah.
Well, I would disagree, but that doesn't matter.
Oh, so you're asking us not to assume anything, but you do. You know it, right? When we agreed with you that we didn't assume anything, you automatically had to say, "Not me, mate."
You do assume.
Okay, maybe. Okay. Anyway.
And maybe, where's the maybe come from?
Because I just want to go forward and...
go on then, carry on then.
The actual reasoning.
We're starting at the very beginning. We're assuming nothing. Yep.
And this goes for all parties involved, so you have to assume nothing as well.
Well, no, he's leading us through it, but... Okay.
I'm trying to assume nothing right now. Trying my best. So,
how's it going for you?
We'll see. Okay. So we have. So we know nothing about the shape of the Earth, and where we're standing, we can still define the vertical direction, right? We can take a plumb bob, we can hang it, and we can see what the vertical direction is. We can move to another place, And we can also hang a plumb bob, and we can see the direction it is hanging, and it is hanging in some direction, right?
Yep.
Would that direction be the same as the first direction? They are hanging in the same direction, yeah?
That is the question.
Well, that's the vertical. Okay, that's...
When
we
assume nothing, we don't know.
We're not assuming anything,
we're not
right?
assuming anything.
Only what we can do, right? So you said at the beginning...
Only what we can see.
Yeah, at the beginning, we are sorting out what we can do. Now, you say we can use a vertical, right? But I would say we would use geometry, because geometry means earth measurement. Okay, so we're going to use earth measurement, and then we're going to have 2 frames of reference within this way to measure things, right? We've got your vertical, and we have its perpendicular, which is horizontal, right? Now, we've got 2 tools that we can use to measure with as well.
Okay, but
we've got a plumb bob
horizontal things
and a level.
Okay, sure. But let's focus on the plumb bobs for now, because they are really interesting in themselves.
Okay.
So now we have 2 plumb bobs in 2 different places, right? And the question is now if the directions they basically how do I say it? I'm lacking a word. Mark, let's say.
Yep.
Is that the correct word in
perpendicular?
This context?
They are.
So
we're going to call them both vertical. Yeah.
Yes. So we call. So the plumb bob at point A is vertical at point A, and the plumb bob at point B is vertical at point B.
Yes.
We have two lines basically marked by those plumb bobs, and now we want to know whether they are not whether they are vertical, because we just defined them to be vertical. Whether they are parallel. That's what we want to know.
Okay.
We want to check.
Yeah.
We don't assume if they are parallel. We want to check.
Okay.
Right?
Brilliant.
Perfect, I'd say.
Yeah. Sounds great.
Okay. So now there is a method of doing that.
Okay.
And it would be easier if I could draw. Can I show my screen? Will you be able to see if I try to show my screen?
Okay. Do you... Yeah, I should be able to.
Yeah.
You know what... when we use geometry, we can use the perpendicular, right? You know, the right angle is a vitally important way of measuring. It's because the right angle lets you form a triangle, and we can use that triangle through geometry to measure distances and angles and stuff, right?
But we don't need actually the perpendicular, and what I want to say...
So you just need a straight line?
Yeah, we just need a straight line that would intersect both those verticals.
Sorry?
Okay.
That is a... Yeah. You need a...
Okay, you should be able to see
Okay.
my screen. I just forgot to launch thing. Okay, can you see the blackboard?
I can see black, yeah.
Yeah, I can see a black screen with some icons at the bottom, yeah.
Okay, yeah, that should be it.
Okay.
Okay, so now what we have is... So let's say... Okay, I have to draw the surface of the Earth in some shape, but let's say we don't know...
Let's do a straight line.
Okay, maybe
which is what we observe.
No, you can draw whatever he wants.
But
that's
maybe a straight line.
That's
it makes
the horizon,
no difference.
Right? We're looking off into the distance.
We just need to remember that we make as few assumptions as possible.
Okay, are we looking out onto the distance?
A point A, and we have a point B.
Yeah.
No, it's not looking at into the distance. It's basically we hang a plumb bob here. So let's make it a straight line as well.
Yeah, a plumb bob. I mean, if there's any straight lines, it's that one, isn't it?
So we basically have 2 straight lines, right?
Yep.
And they are basically marked by plumb bobs, right? Sorry. So here is a plumb bob hanging from something, and here is a plumb bob hanging from something, right?
Okay.
Okay, and now we want to know if the lines are parallel. I drew them parallel actually, but we want to know if lines marked like that in reality would be parallel.
Okay.
So what we can do? we can choose some point on this line, any point really. Let's say it's this point.
How are you going to define that point?
So basically, what we would do, and what was done in the video I mentioned, the point would be marked by a mirror, for example. So
a mirror.
You basically, yeah. So you put a piece of equipment here that has a mirror in this place.
So you mean like a tripod with a...
Yeah, it's on a tripod, yeah. Yeah.
Okay. So, but how do we know where that is?
We don't. It's a random point. The only thing we know.
Okay. So there's no actual need to have a plumb bob there at all.
Well, yeah. The only thing
you've just got a mirror there on a tripod.
Yep. But the only thing we know, and what is important, is that it's vertically over point A. So
all right, okay, so that is a refining marker then, right? You are above a point, so that point, yes. A, right? How are you defining that?
We can mark it on the surface, for example, with some nail
could we
or something like that.
Yeah, could we not just put a nail underneath the mirror and then call that A?
Yep. Okay, but the important thing is...
it's just a random point somewhere with a mirror over the top of it.
Yeah.
Brilliant.
But the point is that we will need to move the mirror later and put something else in its place. So we need to know exactly where the point was.
Okay.
And we will know that by knowing that it is directly vertically over the point A that is marked by a nail in the surface, right, in Earth.
Okay. Yeah.
It is directly vertically that. So that's what we need the plumb bob for, and we will know the height here. Yeah. So we will know the distance.
How exact are you going to make that? Right. You know, when you say that the mirror, like what point of the mirror is going to be above A?
The center, probably.
The center, and what is A? It, like you said, the top of a nail, like the center of the top of the nail. How exactly are you going to be on the center of the top of the nail, and how exact is the center of the mirror going to be over the center of the top of the nail?
Yeah, with the surveying equipment, you can easily have like millimeter precision.
Okay, so just within the millimeter then.
Yeah.
Okay.
Within a millimeter is enough.
Okay. Yeah. On a mirror.
Yep.
Okay. And that mirror would be what? Set at vertical, would it?
Probably, approximately. I would expect it to actually be a retroreflector, so it's not that important whether it's vertical or not, because it will always reflect the ray right in the direction it was coming from.
Okay.
But I'm not sure about that, to be honest. I would need to get to know a bit more about the equipment surveyors use, because that's... But yeah. But the setup of a tachymeter is basically such a mirror, and then in the other point, also above a point marked in the ground, you set up the tachymeter, so it's also on a tripod.
Yep.
And you can also measure the height here with the precision to about a millimeter, I would say.
Okay, so that's the height of that unit.
Yep. And what it has...
Would you need the height of the other bit as well then?
Yep. You need the height exactly here as well.
So that's just, I mean, at A, or... do you
need the height at A, you need the height at B. They might be different. They may be different. It's not important if they are the same. But you just need to remember at what height you have the mirror at A.
So you do need to measure the height of the center of the mirror at A?
Yes.
Okay.
Yes.
Oh, well, that's what I was asking you before, but you said it was just a random point. I take it you need to know the distance between A and B as well? Or is that not really important either?
It's not really important, but tachymeters provide you with the distance.
Oh, fancy kit.
Yeah. So basically, now what happens now is the tachymeter is the piece of equipment that lets you very accurately measure the angle from the vertical direction to the direction to the mirror. So basically you have something like that.
Right to the center of that mirror, to the millimeter.
Yeah. And you can measure this angle.
Okay.
This is called the zenith angle. Zenith angle? Zenith? I'm not sure how it's pronounced. But it's called the zenith angle, and because it's angled from the zenith, from the local vertical direction.
Because it's a personal thing for that particular unit.
So you can measure this angle.
Mm-hmm.
Let's call it alpha, let's say.
Yep.
Now what you can do, you can reverse the roles, so you can then dismount the equipment and then put the tachymeter at point A and the mirror at point B.
Yep.
And now it's important that you know the heights, because you need to put the mirror at exactly the height that the tachymeter was before, and the tachymeter exactly at the height that the mirror was before, so that they are in exactly the same points, except reversed, right?
Okay.
And then you can measure this point, this angle, sorry, and call it beta.
Yeah.
Right? So now you have measured the two angles. You have measured the angle from the vertical at A to this line of sight, and from the vertical at B to this line of sight.
Yeah.
And now, according to Euclidean geometry, if this line vertical at A is parallel to the vertical at B, then we would have alpha plus beta equal 180 degrees, right?
Yeah.
Right. So the point here now is that if you actually perform this experiment in reality...
Yeah, well, wait a minute. Just before you finish there, right?
Mm-hmm.
That line at A that has beta on it, that's a straight line, right? All the way up from A, all the way to the top. Yeah?
Yes.
So can we label that underneath? That underneath angle from the opposite of that 180, yeah, that one there. Call that another angle, right?
This one?
Yeah. Yep. Right, so could we call that alpha? Right, because alpha and beta would equal 180.
If the lines are parallel.
The lines are if the lines are a straight line and B is one angle, the other part of it must be A, right?
The other part of it must be 180 degrees minus beta.
Yeah, and so that would be A, right?
We don't.
Right, okay, well let's go to the other side then, right? That one's called.
That because we don't know
all right, but let's go to the other side. That's a straight line.
Yes.
And then that other one there must be. Okay, right. So yeah, two straight lines, and because that's Euclidean geometry, right?
Yes.
Okay, so that's alpha and beta equals 180 degrees.
We don't know that.
And it works. It works on the right hand side, alpha, and we call the other one beta, and that adds up to 180 because it's a straight line.
But we don't know.
And then on the other side, you've got beta, and if we call that alpha, then alpha and beta would make 180 degrees, right?
If it was beta, then yes, but it turns out that it is not beta.
No, but no. Listen, no. It is a straight line, right? So
this one is straight, and this one is straight.
Yeah, but you've labelled beta there, and now beta and the other angle must add to 180 degrees.
Yes, that.
Okay, right. And then on the other side, alpha and that other one must equal 180 degrees. I mean, this is in Euclidean geometry, right?
Yes, that I agree with. That's why I...
So alpha plus beta equals 180 degrees. I mean, right? Isn't that, what do they call it? Is it... Oh, wait a minute. I think it's called the Bridge of Asses.
Wait.
Right?
Because you're running to conclusions here.
No, it's a proposition within. I'll just have a look.
It's true that beta plus gamma is 180, and it's true that alpha plus delta is 180.
Well, there you go. With two straight lines, got to be parallel.
No, we don't yet know if they are parallel, because we do not know if alpha plus beta. We do not know if this is 180 degrees, and in reality, it isn't. That's the point. If you do this measurement, then you will get
two straight lines, 180 degrees each.
Yes, but they are not parallel.
It's the first theorem.
You're saying if you do this, have you done this?
No, I haven't.
Well,
Okay, so
no,
you-
the geometry, right? Can you not see that geometry works? So, if alpha and beta make 180 degrees, then that one on the right hand side there, logically, must equal 180 degrees, right?
No, logically, beta plus gamma must be 180 degrees because this is a straight line,
No,
and alpha plus delta
you
must
see,
be 180 because
I don't think
this
what
is
you're getting at. It's a four-sided shape that returns back to the same side, right? It's just a quadrilateral that has 360 degrees. I mean, what?
It would be if those are parallel.
No, it is that because of geometry and logic. It's not because they're parallel or anything. That works like you've just described it because of geometry.
Okay, let me put it this way. If you have this line, and you have this line, and now you have this line, we still have 3 straight lines.
Yeah. And then when you do those things and add them up...
this angle beta plus this angle alpha, does this equal 180 degrees? Some of these angles. In other words, is this here gamma? Is gamma equal to alpha? Because I don't think so.
That would add up to 180 degrees, right?
Beta plus gamma equals 180. Yes, because they are on the same line.
Yeah.
But beta plus alpha is not 180 degrees here because these lines are not parallel.
Okay. But the way you labelled that up, can you go back to the one that you just did? Yes. Right? Yeah. Wait, what doesn't work there?
What doesn't work where? Here?
Yeah.
That beta plus alpha is 180 degrees. This doesn't work. Well, we don't know this until we make the measurement. It could well turn out to be 180 degrees.
Okay.
It could turn out to be 180 degrees.
It relies on a measurement then, right?
Yes, that's true.
And
we need to measure
who's made this measure? Have you done this?
I have not. I intend to.
So who are we trusting with taking these measurements? Because it's pretty vital, right?
You can trust no one. You can just... I only presented you the method. You can do it yourself.
We can what? We see what we choose to do, right, is to make sure that the horizontal goes from one of those to the other, right? What's up with that?
My point is you can make this measurement yourself and you can see if alpha plus beta will equal 180 degrees. And I bet you it won't.
You bet. Right,
Yes.
so you actually don't know.
I haven't made this experiment myself, but I'm confident that it won't equal 180 degrees based on my knowledge about the world.
Have you ever been to a bookmaker's?
Sorry?
Have you ever been to a bookmaker's?
No.
A betting shop.
And tried to place this bet?
I could.
You could? Have you ever been there?
No, I haven't.
Okay. Well, try, please. Because if any money you're willing to match, I will match it with level is horizontal. Because they won't take that bet. That level is horizontal.
Anyway, my point is you don't have to trust anyone. Renting such an equipment, a tachymeter with a mirror, it's not that much money.
Okay,
I checked, and in Poland you can...
Who's done it?
In Poland you can rent such an equipment for like £50 a day in converting the currency. So for £50 you can just rent such an equipment, perform the experiment and see for yourself if two vertical lines at different points are parallel.
So have you just decided this? Have you been working on this for a bit? When did you come up with this method? The tachymeter method.
Come up? I can say I came up with it because the idea was I got the idea from this video by the main surveyor.
By Jeff.
But the method is Yeah, but the method is purely geometric. It's just geometry. You just measure the angles in reality.
What he did. Was his not good enough for you?
Well, it is good enough for me. So basically, he made this measurement and he got the result of 180 degrees and 15 arc seconds. So more than 180 degrees.
Yep.
And actually, these 15 arc seconds is above the uncertainty of this measurement. Okay. So this is actually
what that implies, right, is that the horizontals that are perpendicular to each of those verticals intersect at a midpoint between the two.
Yes.
Okay. Now, have you seen our test for a water level?
Mm-hmm.
Right.
Now, Bev, can I just take an aside here just for a second? Are you actually going to rent this equipment and do this test?
I intend to, yes.
Okay, and what sort of timescale are you looking at to rent this equipment and do this test?
That's the problem, because probably I won't have an opportunity to do that during the next few months due to various reasons.
Right, so you're looking at next year, yeah?
Yes, unfortunately. I would be very happy to do it during the next few weeks even, but I probably won't have the opportunity.
And what kind of distance are you looking between your emitter and reflector?
In order to have I lost the word. But in order to have results that actually mean something, or meaningful results, you need a distance of, let's say, half a kilometer at least. Well, half a kilometer, it's even more. I think the main surveyor did this with a distance of 1,000 feet, so this is about 300 meters.
1,600 feet. Hey, do you know what, real quick? Do you look at the difference in the verticals and extrapolate that degree out from that distance? Do you realize how small the ball would be that you think you live on? Do you understand what I'm saying?
Not that small. I actually did the calculation.
Yeah. For the main surveyor's 1,600 foot measurement, would they, what was it, 3? Was it a 3 degree inclination?
No, it was 15 arc seconds.
Okay, no, it was one of his drawings. He has 94 degrees.
Yeah,
one of his early ones. Yeah, he's
What?
Do you want me to get you that? Yeah, I've been dealing with these people on Twitter for quite a while now, and
but the point is, this was not a horizontal line, so the sum of
Jeff did make a drawing, right? I'll sort it for you now.
I think
Do you think it's possible that maybe the main surveyor maybe tricked you into believing something that's not really going on about that?
No, but the problem
is... 100% trust him, right?
No, I don't have to trust him.
But you haven't done this yourself?
No, but I intend to, so I will check that.
So you are trusting him?
Right now, okay, if you want, but I'm not just trusting him, because this basically matches...
guys, right?
No, it matches up with everything else I know about the world.
Why don't you check with an outside surveyor who's not Jesse, Larry, or whoever?
Yeah, sure, I could do
there
that.
You go.
That would be a good idea.
Right, see there, in the bottom right-hand corner, it does say...
Yeah, I see that.
Hi, my name's Jeff. My name's Jeff. But if you look under the bottom left-hand corner, it's got KC. Now, KC is a Canadian, she says lady, but I'm not too sure, that pretends to be a mathematics teacher. So she's made this meme, and she's took Jeff's picture.
Yeah.
Which is sort of what you're saying, isn't it?
She's the one that doxed you, isn't it, Bev?
Well, she's the one.
She claimed we doxed her when she did it herself.
She put a picture of herself.
She put her own name on there.
Yeah.
Yeah, that's crazy. When I look at these angles right here, I'm like, this doesn't work for your ball.
Yeah.
What's going on here?
Is that the sort of thing that you're looking at?
Something
in debate discussion.
Debate discussion. This. Oh.
Yeah.
Okay.
It's on live stream, isn't it?
Well, no, but he can't get into live stream, can he?
Okay.
So they did a modus tollens for him as well, because she doesn't understand logic and she had to sort of let everyone know. So you can have a check over that if you want, but don't laugh at it too much.
Come from?
Jeff, I don't know, Jeff. Look at the bottom right hand corner there. It's your mate.
Yeah, you can.
He's made them. He made this whole thing, right? He made that to prove your point that you're trying to do now.
I think you wrote that down.
The angles I've seen in the video were not these angles. And
but this is a meme that Casey's made, and they all use it. Or well, they used to use it for a bit. I don't know.
Okay, perfect. But I would very much love to see where these numbers came from. Because
you don't. No, you don't. This is Twitter. This is how your people work. I mean,
you should check with the main surveyor.
Like, just look at it.
Yeah, except
just look at it.
Yeah,
looking at it, and I don't know where these numbers come from.
Well, they come from there on the page. It's got the main surveyor's thing in the bottom right-hand corner. He's your guy that's measured this. Yes.
Can you show me something that was made by the main surveyor?
He can write some. He can write some numbers down on his book.
Because I could show you right now the video.
Is that not good enough for you? Is that not good enough for you?
This picture? No, it's not.
But Casey's done a modus tollens.
And get in touch with the main surveyor and ask him if he did this.
Yeah.
And ask him what it means.
Yeah, sure.
Yeah.
I could.
In fact, I'll tweet him now and see what he says.
Why not? Yeah, I can do it. I will do it. Why not? I will link to him this Twitter? Meme and ask him. Yeah, I am.
Oh yeah, ask him what to explain it to you.
What are you on Twitter?
Do you see the problem with this right here? Do you see?
Of course,
the problem?
That would mean that there is an over 8 degrees of inclination between those two plumb lines. So that would mean that this measurement,
size of a small town.
Yeah, such measurement would have to be made over the distance of like 1,000 kilometers or even more.
Yeah, and that is
way beyond. Yeah,
ridiculous.
No, actually about 900 kilometers. Yeah.
Okay,
but these numbers are ridiculous.
Yeah. 900 kilometers, not 1,600 feet. Yeah.
Yeah, but the numbers he gave in his video, actually his video and not an image propagated by someone else, where of course there was an angle like 94 degrees on one side, but the angle on the other side was around 86 degrees.
Yeah, see, he always puts his image down on the bottom right.
And the actual sum was 100 degrees, 0 minutes, and 15 seconds. This was the actual sum, and the 15 arc seconds over those 1,300 feet, I think, were there.
Do you know what he's trying to do by doing this downhill like he did in the video? Do you know what he's trying to prove to you?
No.
Do you know what this technique is called?
But it doesn't. The point is, this doesn't matter if he's doing it downhill or not.
Answer the question.
Do you know what this technique is called? It's called reciprocal leveling.
Oh yeah.
Have you ever heard of that?
I've heard the name, yes.
So you don't know what it's used for. Do you know what it's used for?
To be honest, no, I'm not that.
Okay, it's used for exactly the opposite of what he's inferring to you about curvature. It's used to eliminate the distortion of perspective compression and refraction over a greater distance. It's not used for what he's showing here. He's tricking you. Okay.
But this is actually a good method of checking that the vertical lines are not parallel.
No. Their plumb lines are plumb lines. They are vertical. They don't deviate.
And not parallel.
You know what? This guy is soldiering you up. So you're out here fighting his battle for him. He's making you look stupid because
no, not
you don't
really,
understand.
Where do you see him presenting his own arguments? Ever?
Nowhere.
Send him that link as well when you send it. Tell him he can come and talk.
You are presenting his fallacious arguments.
No, it's not. The problem is that
he doesn't come out and defend his own arguments. Do you not
wait
see
a minute, we're live. I've sent him a link that we're live, and I've asked him here just to confirm that is his drawing, right? And we're telling him we're going over it now, live.
Okay, sure.
Yeah.
Anyway, the point is I might have stumbled upon this argument on his video, but I actually understand the logic behind this argument.
But you don't even know what the technique is. You don't even know.
Refine the method, right? He's
the name.
He's give us another method to measure curvature. I like it.
I might not have known the name of the technique, but this is, as you like to point out, pure geometry.
Do you think
measure two angles, and
two
if the
points.
angles sum to 180 degrees, the lines are parallel. If they do not, the lines are not parallel. It's that simple.
Would you have measured a curve or a slope? What do you reckon?
What do you mean? No,
when you do that,
we are not measuring either right now. We are only checking if two lines are parallel. That's the point.
Right, so you're not measuring a slope or anything in between. You just you're trying to measure if lines are parallel?
Yes.
By measuring an angle.
Two angles to be precise, yes.
Yeah, but how does that mean that the
because if the lines were parallel, then these angles would have to total to 180
No,
degrees.
couldn't the line in between them be sloped?
It could, but the sum would still be 180 degrees.
Okay.
The point here is that it doesn't matter if the line is sloped or not. That the slope of the line only affects the individual angles. So the angle on one side might be, for example, 100 degrees, and on the other might be 80 degrees. But if the lines are parallel, then the sum will always be 180 degrees.
Okay, so in between them, right? If you to check it properly, you put a horizontal, right? You would make a line of even in between the two.
But we don't need a horizontal here.
Pardon?
It's not necessary at all.
It's not necessary to what?
To check if the lines are parallel.
So you do you can just sort of you'll do this without even using a horizontal line to connect the two geometrically. So which point would you be using?
You clicked out, Bev.
Oh, sorry. Which point would you be using within this to connect your lines?
I'm not sure what you mean.
Well, because you're just measuring if lines are parallel or not.
Yes.
Just lines or particular lines?
Just lines. No, these vertical lines.
Oh, vertical. So you're measuring whether verticals are all vertical, or whether vertical. What? Go on.
No, I'm checking if verticals at 2 points are parallel. I know that they are both vertical because I basically marked them using plumb bobs, so that I know that this is the vertical direction and I know that this is the vertical direction. Well, actually, I think the proper equipment has some more sophisticated methods of making it properly vertical than plumb bobs. I'm not sure what that is, but it has some other methods. But the point is that, well, it can measure angle from the vertical direction. That is what is important here. So
okay,
we can accurately measure this
how far is
angle.
your vertical that you're using as your frame of reference, right?
What do you mean?
Well, your vertical that you're using, that's a vertical, because, right, you're measuring things with a baseline, right, and an angle is measured in between two straight lines, right, the inclination of two straight lines. So, where is your vertical line that you are measuring from? How big is that? And what sort of a check do you have for establishing your vertical?
I don't really know what you're asking about, to be honest.
Well, the vertical, the machine or whatever. What is your thing that you're using as a vertical in order to measure your angle? Yeah. Because obviously the point that you are measuring is the bit that you're looking at. Yeah?
Mm-hmm.
Where's the other line that you're you're making?
The other line?
Yeah.
Well, to be honest, I will have to guess here because it depends on how exactly the equipment works. But I would expect that modern equipment has some kind of an electronic sensor that tells it where the vertical direction is.
You think it'd be vertical, do you think?
Well, yeah, it probably works on the basis of some weight or something like that basically is being pulled down in some direction, and then the sensor can determine very precisely where that direction is. But I'm guessing right now. I would have to check in the documentation of the equipment.
Yeah. In order to level something, in order to measure something, you have to align it with the horizontal, right?
Well, I think this equipment probably just detects the vertical direction, and then the horizontal is 90 degrees from that, so you can use it to also mark the horizontal direction.
There's no way that it could possibly reference the horizontal and take 90 degrees from that to make a vertical.
No, because horizontal is also defined by the vertical direction. So
okay, so the one of them is as good as the other. Brilliant. I mean, that's where we wanted to get to. That's why perpendiculars are so important, right? When you're dealing with straight lines. So if you're dealing with one, like the perpendicular is basically the same, just 90 degree different. So they're basically the same line, right? The vertical and the horizontal, they're much the same, but it's just much easier to reference the horizontal, right? Because you can make that longer, can't you? I mean, like you've just proved, you're struggling to even know how they reference the horizontal, the vertical.
Yeah, sure. So you could use this to make this line horizontal here. So you could use this to make this angle equal to exactly 90 degrees. But then, if you measured this angle, it would turn out to be larger than 90 degrees. So the line wouldn't be horizontal at this point. So the line that you made horizontal here wouldn't be horizontal here. That's the point.
Okay, so like I say, your horizontals intersect. Yeah?
Sorry, you cut out.
Your horizontals intersect.
Yes.
Right, well, why don't you measure the horizontals in straight lines and check that they don't intersect?
Because it's harder.
It's not, because you just use water levels like we've done.
But the water levels don't mark horizontal lines.
Yeah, they do. It's a tool for establishing a horizontal frame of reference.
No, they do not.
Go back onto my video, right? Can you see my video?
Wait.
Because I
was going to just say, wouldn't a horizontal against the plums tell you if they're parallel? That's the easiest way. You have your two plums, then you just put a horizontal. If you get 90 degrees everywhere, they're parallel. You don't need to mess with anything else. Just put a horizontal against your plums.
Not really, because you have no way of being sure that the horizontal you marked at one point is the same as the horizontal you marked at a different point.
That's the point of establishing a horizontal. Do you not understand? This is Bev's entire point. The entire point of establishing a straight horizontal you can then use to determine your plums if they're parallel. Everything starts with the straight lines. And you're saying, we do it without that. That's crazy.
And then it will turn out that the plums are not perpendicular to the line you called horizontal because you moved to another point and the plums started to deviate from the direction perpendicular to the horizontal.
Come here.
That's the problem.
Right.
Yeah, I'm seeing.
You're watching it, right?
I see your video.
Now we are on. This is one of the ballers. He's crying. Now, this is at one end of a mile, and it's a water level. And this guy's he's stood at the side of a canal. He's got a plumb bob in his hand, and he's dangling it down here. And this water, in the water level, is at the side of a canal. Now, when he holds his plumb bob at the side of a canal, he's there. When it hits the surface of the water of the canal, right by the side of where this is, that plumb bob hits the water of the canal, and it's horizontal, right? One's horizontal, and the other one's vertical. He does that there. Right, now we're going to make this 1 mile long tube and we're going to fill it up. Yes. And the water is going to equalise from here to here. Mm-hmm. Yep. then we're going to get 2 half-mile water levels. One here, but it only goes halfway. And then one from here. And that comes halfway as well.
Sure.
Right, now. From here to here, it's level, right?
Yes.
Okay, that means...
That image just flipped over on YouTube. I don't know.
I know, because that's me, I know. That's what I said. It does it to me all the time. I can't get it to do it.
All right.
Right, so it goes from there to there, all the way across. And these ones are level as well. And that's level from there to there. And that's level from there to there. Right? All 3. Yes. On the same level.
Mm-hmm.
If you were to draw a straight line from here to here, would this be here if we were to tap another bit in? Would it be the same line? Straight line?
Nope.
No. Okay, right. So we'll just do that. Right? Where would it be?
At the same level as the middle two.
It's the same as these two, but these...
Yes, of course.
This one here and this one here are the same level.
Yes.
Not up, not down.
Of course.
This one here is at the same level, and this one here is at the same level.
Yes.
Yeah. Now this one here is at the same level, not up nor down as this one.
Sure.
And this one here is the same level as this one, and it's not up nor down from this one.
Sure. Sure.
So this one here must be at the same as them because it's the same at this end.
Sure.
Yeah?
Sure, and it would be.
Okay. Then when you go like that, there, they're all on the same level.
On your board, yes, but in reality, they wouldn't be on the same line.
But we've just gone over them. They were at the same level and the same level and the same level.
Yes.
But now you want to lift it up.
On the same line.
Right, so you want to lift this up a bit.
Yes.
And then you lift this end up a bit.
Let me post an image.
But no. Just can we just go over this? If you lift the middle bit here, you lift this bit here. And you're going to lift this bit here also. Which would make this line from here raise up. It wouldn't be on the same level.
No, it would be. Because the level is not a straight line. Look in debate.
Level is not a straight line. Did you just say that then?
Yeah, it's not. And this experiment also has been performed, and we discussed about it the last time.
See this one?
The middle.
See this? Is it curved?
Yep. Of course not.
So this is a straight line?
Approximately.
Right. Here we go. We'll try this again. Is this straight?
Up to some precision. I don't know what the precision is of
okay, so
of this tool.
Well, this is a dual. It's a. Well, in fact, it's not. It's on the level. .live.
I mean, I'm even pretty sure that
level.
This is not exactly straight because exactly straight doesn't exist. There is always some inaccuracy.
What about this then?
Except that.
When you look through that scope.
Yeah.
What do you reckon? Is that straight? With the crosshairs.
Approximately.
The crosshairs on the optics are straight. Or
Also
the view that you take when you look through it.
Up to some precision.
Okay. And what sort of precision?
I don't know.
I'll tell you. The auto level is accurate to 1 millimeter over a 1 kilometer double run.
Okay.
That's 1 millimeter. Okay.
Okay.
And can you just go over the rate of curvature that you think a level isn't a straight line as? Do you have a number off the top of your head?
Yeah,
level
it
level
depends on
curves at the rate of. Go on.
Yeah, it depends on what you're exactly asking, but I guess you're looking for this 8 inches per mile squared or something like that, which
so
is
8
also
inches
approximately
per
okay.
mile squared is a measurement of curvature?
Approximately, yeah.
Can you explain to me how that works?
How that works? What, this 8 inches per mile squared?
Yeah, as a rate of curvature, because you've just sort of... You've said that's a curve, right? That's what, in your imagination, that's what level that isn't a straight line that you say.
Yep.
Okay.
Because it isn't.
And
you can check that in exactly the method that you presented on the board, and this is what we discussed the last time. You can just do this experiment, and then you will see.
Are you looking at the board?
Levels...
Are you looking at the board, right? This line here is that is called a horizontal, and this one here is called a vertical.
Yeah. The problem is your drawing doesn't correspond to reality.
Sorry?
Your drawing doesn't correspond to reality.
That's not
what reality?
That's not a drawing. To? That's a laser level. Look, I can switch it off. Look, whoa!
Hang on.
That is a reality tool.
And you did agree that the water in those water levels expressed on Bev's whiteboard would have a horizontal plane all the way through them.
No. I didn't agree on the horizontal plane all the way through. I agreed that the levels of water in the different files, or what do you call them, would be on the same level at the same point. Like, if you look at point A, then the red and purple one would be at the same level. If you looked at point B, then the red, purple, and blue one would be at the same level. And if you look at point C, then the blue and purple one would be on the same level.
So it is a horizontal plane?
No.
See this?
No, it's not.
Look.
I made a drawing to make this more explicit. Look. So if you look
at... Can you see that plumb bob there?
Yes, I can.
Right, now, this is a level. If I put this perpendicular to that plumb bob right at the middle... There.
Except it would look a bit different over the actual...
Listen, let me finish. Look, it's quite heavy, this level, actually. If I put it there and make that perpendicular to that at the point in the centre and draw a line across it, would that line be parallel to a line drawn from this end to here?
Yeah, I think so. If it's exactly in the middle, then yes.
That one would be horizontal, and the line parallel to it would also be horizontal, wouldn't it?
Yeah, sure, at this point.
So that, from there to there, would be horizontal.
Horizontal at B, yes.
Yeah. And just the same as from here, from the end of here, to the end of here. That would be horizontal.
Easier if you just looked at the thing I drew, because...
Yeah, but hang on. I'm looking at the thing you've drawn, right? And Bev has just described the blue on the right-hand side to the blue in the middle as being horizontal. The same as describing the purple on the right-hand side to the purple at the extreme left-hand side as being on a horizontal. And you have just agreed with him on that.
No, I agreed that it would be level, not that it would be horizontal. That's the point.
Another water level in here.
But they are not.
How can one be a horizontal and not the other?
Exactly as in my drawing. You would have the surface of the water follow the level.
It's describing two different attributes to horizontal. One is curved and one is straight. How can you have the same
There's a difference between level and horizontal?
We're describing horizontals. And you have got one that is level, a straight line, and one that is a curve. How can the same word have two different opposing attributes? Have you heard of the law of non-contradiction?
Yep, but the point is the contradiction is not there in what I said. It's what it's in your understanding of what I said.
No, don't come with the you don't understand. You have described one horizontal as being a straight line,
No,
and
no,
the
no.
other as being
You
a
said
curve.
it's horizontal. I didn't say it's horizontal. You did.
You have just drawn it there.
Where did I? What I've drawn,
Just put another
I've
one
drawn
in.
the yellow line,
that's
and
good.
the yellow line is straight. But the yellow line is horizontal only at B. It's not horizontal at A, it's not horizontal at C, it's not horizontal from B to C, it's not horizontal from A to B, it's only horizontal at B.
So you've got no horizontals that are straight.
No, a horizontal line is a straight line, but it's only horizontal at a single point, and we've been
No,
over
it's not.
this.
A line
What the hell are you
cannot
talking
be
about?
A single point. We did this at the beginning.
A horizontal,
said
a horizontal
it's a single
line
point.
needs to be a
I
little
never
bit longer
said
than a
it is
point.
single point. I'm only saying it has a property at a single point.
What?
No,
So
I-
horizontal is only a property of a point.
Fucking hell.
So there's no such thing as a horizontal line.
No, the horizontal is a
Oh,
property of a line.
you've
at
just
a point.
completely took away a horizontal line.
Does Euclid know about your definitions here?
Do you know?
Sorry,
Does Euclid know you are rewriting his definition?
Like, can I just?
but Euclid,
No,
I
wait,
don't
no,
think
no,
Euclid
no,
defines horizontal.
please stop it. What you're saying is that any line that is perpendicular to a vertical, right, is horizontal, but it's only horizontal at the point it's on the vertical.
And that follows.
Okay, so then,
quite
so
nicely
that
from the fact
dictates
that
that all horizontal lines are on, well, all horizontal points are on
Not
the
really.
vertical. They're basically the same thing as
No.
the vertical.
No,
Yes.
what I'm
Wait,
saying
wait,
is
where
that
does the horizontal
being
extend
horizontal
beyond the point of the vertical, please?
only means that being horizontal is a local property. It's only a property.
It's
that is
local.
valid
It's local
locally.
to the vertical.
And you can't use local unless
If-
you can
if you
define
make a
what local
horizontal-
is.
If you make a horizontal at B, this line is not horizontal at C. If you make a horizontal at C, it's a different line than
listen.
the one you made
If
at
you
B.
make the line from A to B, that is a horizontal line.
It is not.
Well,
It is a
what
it is
line is it then?
It is just some line connecting A to B
Okay, so how do you make a horizontal line then?
by using something, I don't know, something like, for example, this auto level of yours. But it was
So
just
you're making an
tangent.
argument from something you don't know.
No,
An
well,
argument
so
from
I
ignorance.
okay,
Oh,
I
my
get
Also,
a horizontal
absolutely
then, right?
incredible.
Also, you can actually
Incredible.
also use a water level, except you need to do it on a shorter distance because basically this way you better approximate the tangent. The horizontal is
But
tangent to the
a
level.
water level is more accurate over longer distances. So
For
you-
leveling, yes. For establishing a single level, yes. Not for establishing a horizontal.
A single level is a horizontal.
No. Not
Yes.
over long distances. Over
Yes,
short
it is.
distances, approximately. Not over long distances.
Prove it.
Well, the proof is, for example, if you do this experiment with this triple.
Well, go out
water
and do your
level.
experiment. Don't come here and lecture us about something you know nothing about.
Okay.
Go out, do your experiment.
His
and
is
bring
an
back your
experiment.
results.
Wait a minute. How does he get
Well, yeah.
experiment status?
It's an observation.
Yeah. So basically, we do this, and then we check if
Well, go
the
on then. Off you
if
go.
the water surfaces
No, don't tell me
surfaces
to
line
do
up.
that, DP. You
Don't
can't
a straight
tell
come
me
line,
that.
or
and
if they
lecture
don't.
us on your belief system. Come back
Okay.
when you have proof.
Okay. Why not? By the way,
Go
you can
away.
also do this
Go
experiment.
away. Do your. We've got an experiment of our own. Well, a test of our own, an observation of our own. Thank
okay.
you. We don't need
Let's
yours.
let's not
Okay.
let's not
so we
run
have
away
now
just
two
yet,
methods
right?
for testing. We have
Because
two methods for testing. You can check now if the verticals are parallel, and you can check if the water surface over long distance actually forms a straight line or not
well,
using this.
do you want to
triple
do the
water level.
logic first?
I think we actually did all the logic that is necessary here.
Okay, so the logic proves that it must be horizontal then, right? It
No.
must be all on
No,
a straight line.
Logic proves no such thing.
No such thing as a horizontal now.
No,
Do-
I'm not saying there is no such thing as a horizontal. I mean,
You just said there's no such thing. Bev said it's all on horizontal. You said there's no such thing.
Yeah. I think
prefer to do
I
something
think
wider than
we have
just horizontal.
can we do the elevation thing, right? Do you understand what elevation is?
Yep. Altitude
I don't
above some
think it
level.
really understands anything, Bev.
It's
a
a
pointless
vertical
conversation.
a vertical change in distance, right?
Yes.
A height change above sea level.
Yes.
A mean sea level. That gets assigned a
And
zero
mean sea level
datum.
is actually, yeah, and do you know that mean sea level is actually a geoid?
Is it? So right. Oh, so that level,
And the vertical
that
distance
is that
from-
that level is
It's a
definitely
geoid.
curved, right?
Yes, it
Okay.
is.
Now, so where have you got your reference from that from? Who's told you that?
You can see it. If you are near the sea, it's quite easy to see.
What's easy
would
to
say.
see that somebody
Well,
says
yeah.
that level is horizontal on the mean
No,
sea level datum.
that sea level is curved. It's quite
Okay,
obvious
so
if
but
you
that
take a look
level,
at-
when you see the mean sea level datum, when you hear that datum, you say curved surface. Is that what gives you the idea that level is curved?
Not only that, but basically all small facts like the one that if you do this water level thing, then you will see that the middle one is actually higher than both ends. They don't line up.
Okay,
According to you.
so they will be
Oh.
higher, right?
Yeah.
Okay, so now the other one is, right, because we're getting this quite a lot. Do you think a surveyor can establish a horizontal datum
Yeah, probably. I'm not sure what
over
exactly. the
over a
surveyors
mile?
do. Probably.
But like a horizontal datum, not to a point, like a series of horizontal points all in a straight line along one line that we can call a horizontal line. All of
To be
the
honest,
points along that line having a property called horizontalness, where
To be honest,
they're
I'm-
straight lines all occupy the same straight lines. Every straight line within the straight line on that straight line would be called horizontal.
I'm not sure what horizontal datum is in geodesy. I would have to check this out to know what the answer to your question is here.
I think so. Good.
Because
So
I'm not sure if this is defined as a surface of constant elevation or if this is actually a horizontal plane.
Just a horizontal, yeah, a horizontal
Well-
plane. Do you think it is possible for surveyors, like professional people that have studied and done that sort of thing, to establish a horizontal plane of reference?
Probably yes.
Jolly good. That's great.
But 5 minutes ago, horizontal didn't exist. Weird.
Yeah, as a even
No, the
beyond
problem
a
is-
point.
They will establish horizontal planes from a single point, and then this horizontal plane will only be tangent to the water level at this point, and it will not be horizontal anywhere else. It will just be some plane of reference.
But that's why I said a horizontal line over a mile that is horizontal at all points along it, because that's what a horizontal line is.
Such a thing doesn't really exist. That's the problem.
Sorry?
There is no horizontal line that would be horizontal everywhere. Well, it is if it is curved, but it's not a straight line anymore then.
Okay. So a water level,
There.
you don't think that a water level has the possibility of establishing a horizontal plane of reference then?
No, it can be used for that purpose, except with some caveats, I guess.
What caveats? The fact
That's,
that you
for
can't
example-
establish a horizontal.
No, that if you take this water level over too large of a distance, then basically the line you will establish will not be horizontal at either end.
Okay. And what
Well,
would it be different at either end, right? Would that depend on which end you were stood at
And
of
what
the
down
water
it-
level?
Both.
What distance?
It depends on the accuracy you need.
Yeah, if let's say there's a slope. You stood at one end and it's a mile, right? Would it have an 8-inch slope downwards
Mm,
to the other
in
end?
a
It's
way,
mile.
although I would prefer to express
But
this
then,
as an
as you
angle,
walk, would that
It's an
water
angle
level not have that much of it? Like by the time you got there to the other end, would it not? Would it have a slope the other way?
Yes.
Right. So, like you'd be walking what you'd be calling it along a level, right? Because you're walking on the level of the water, right? But as you move from one side to the other, the water level behind you drops.
Yeah, I guess you can see it pretty clearly from the drawing that I posted with the water levels.
So if
We're
you're
not talking
at
about
A,
drawings, though, are we?
if you're at A, the water drops to C. But if you're at C, the water to A drops away from you. And if you're at a point in the middle, then both of the other ones drop away from you.
Yes, that's right.
Okay, so that would be easily measurable. Is that why we go along with the fact that Jesse Kozlowski says that you can measure the drop of the water away from the horizontal then?
Yeah, I believe that is measurable, probably using geodesic equipment. Yeah.
Yeah. So
Geodetic.
what we do is we establish the horizontal, and then put a water level up to it, and watch the water level drop from our position. Right. Simple.
Yeah.
Yeah. Jolly good. I'm glad
Jolly
Jesse did that. You can't see any flaws in that plan or anything, can you?
Not at the moment, unless you deliberately described it in a way that I'll miss some details, but...
No,
What you see is what you get.
Easy. Establish horizontal. You said the surveyors can do. Yeah. Establish that line. Get a mile hose pipe. Put it up against the marks that on that horizontal. Fill it up. What could be easier?
Can I just go an aside for the
I'm
minute?
going to make a brew. Yeah. Off you go.
There's I'd just like you to explain something to me.
Okay.
If you look in, debate discussion.
Yep. Looking.
I've put a picture.
The number one city datum.
Absolutely. Number one city datum, right? You were saying earlier about sea level datums. Right, this is a city datum.
Local.
Okay. Local, yeah. But how local is local?
Local city.
So, do you want to read it or shall I?
No, I'm reading it.
Alright, do you want to read it aloud?
Yeah. Please read it aloud. People are listening.
This benchmark designates the primary datum for the city of Chicago. It is from this point that all heights in the city are measured. The city datum is hereby established as a plane 17,640 feet, or 17.640. I'm not sure. Yeah,
17.
I think you use the dot as the decimal point, right? So that would be not.
They decimalize feet in America. Yeah, so yeah.
Yeah, so that would be 17.64, right?
64. Yeah. I'll go with that. It doesn't really matter, but I'll go with that.
Feet below the benchmark cut on top of the bottom stone of granite base at the southeast corner of the Northern Trust Company Bank building at the northwest corner of probably St. LaSalle Street and W. Monroe Street.
Could be south.
Oh, maybe.
South Lesnell Street and west Monroe Street.
Oh, yeah, probably.
Yeah, could be. Because they do. Street orientation is cardinal directions in America.
Oh, yeah, that's right.
But again, it doesn't really matter. The bit that I'm interested in, that you read, is the first line.
Yeah, that
of
is
the
a plane,
second
right?
paragraph. Exactly. Establishes a plane that all building references are taken from in the city of Chicago. This is a reference plane for building very tall buildings. Chicago's known as the Windy City, and you know why, don't you?
I can guess.
Yeah, it's windy, and there's a lot of skyscrapers.
Yep.
In Chicago. And this is a reference plane.
Mm-hmm.
So those buildings are built square.
Sure.
Explain that.
So what exactly should I explain?
Do you want, do you trust maths, right? That's one of one of the proofs that you can have, right?
Okay.
Well, do you know the definition of a plane? Do you want to?
Yeah.
Do you want us to get
actually,
that?
I do. Yeah. So I don't know. What I'm guessing here right now is that it's just convenient for surveyors to measure from a plane, or to just approximate the surface of this size of a city as a plane.
So all the buildings would be sloping away from each other, one side of the city compared to the other.
I guess that the builders of the buildings were using plumb bobs at the point where they were building the buildings. So, yeah.
But
so
this is
vertical.
a datum. All the measurements are taken from this datum plane.
Oh,
So that means the architects and the builders would have to make adjustments in the buildings as they're building them. Because the datum plane that they are using is wrong for the building in that place.
Oh, it depends
I've just
what
put
you
a
mean as
definition
wrong.
of a plane in the discussion if you want to just have a little peruse of it.
Probably a good enough approximation for most purposes.
Doesn't mention anything about approximation on this at all.
No.
If you take something
this is mathematics.
If you take something the size of the city,
you don't see architects working to approximations, or builders for that matter.
Yeah. Well, they just need to establish where they need to build the building and then build from there, right? They don't really.
But there's no adjustments made for anything other than a horizontal plane. Well, there's no adjustments made. All measurements are made from the horizontal plane. There's no adjustments made.
The horizontal is a position, right? You do understand that, right? No, wait a minute. No, don't talk, please. Horizontal is a position in reality that is defined by being perpendicular to a vertical. That means it's a straight line, right? Now, that is just a position. Horizontal, right? As opposed to vertical. A vertical plane is in a position, right, that is 90 degrees opposed to a horizontal plane. Now, a plane in mathematics, which I hope you trust mathematics. Now, within mathematics, it states a plane, noun, a flat surface on which a straight line joining any 2 points on it would lie wholly within the horizontal plane, right? An imaginary flat surface or joining material objects. It's got another one here. In mathematics, a plane is a flat, two-dimensional surface that extends indefinitely far.
Okay. Yep.
So
that's mathematics. You can't rewrite mathematics, can you? You're not the person to do that.
No, definitely I'm not. But actually, you can rewrite a lot of mathematics if there is reason for that.
Like, would you try and attempt to curve a plane?
Yeah, that's not. No, because
it's not possible, is it?
It's a useful definition to have a plane.
You would have to distort it, wouldn't you?
But you don't really have to distort it. It's quite possible that it was convenient for the surveyors in Chicago to use a plane for reference. I'm not a surveyor, so I wouldn't know how exactly that is done.
Okay, but a horizontal plane, right, is regarded as being horizontal at every point on that plane. That's why it's called a horizontal plane. Every point would be referenced to the other plane, right, as horizontal.
Not necessarily.
No, that's what level means. Precisely. It's within the same plane.
Not really.
Not really.
No. You can establish a horizontal plane at some point, but it is perpendicular to the vertical at this point, but it won't be perpendicular to the vertical at another point. Well, unless you don't really care to be so perfectly precise, and up to some precision you're fine. For example, if you need precision to a one arc minute, for example.
Horizontal,
then,
right? In mathematics, the mathematical definition of horizontal would be measured or contained in a plane parallel to that of the horizon.
That's not a mathematical definition, really, because
it just says mathematics. It's there. It's got mathematics brackets.
The horizon is not a mathematical notion, so that's a bit weird here.
It just says relating to.
Yeah, measured or contained in a plane parallel to.
Oh, there is a plane parallel to that of the horizon, but
it's not using the
horizontal.
horizon in a mathematical term, is it? It's just saying relating to the plane of the horizon. It's an equivalence.
Yeah. Anyway.
No, not anyway.
There's another one. There's all the different planes.
Yeah, but anyway, as I was talking before, if you, for example, only care about precision up to 1 arc minute, then you can consider a horizontal plane established at one point, horizontal in quite a large area, and you will still be fine because you don't care about precision of angles smaller than 1 arc minute. And the deviation of 1 arc minute is like a mile or something.
From one side of a city to the opposite side of a city.
You say that they don't care about an angle 1 degree. What was that? 1 degree off?
I said 1 arc minute. 1 arc minute is
1 arc minute of what? Like, where is that 1 arc minute measured in reference to?
No, I mean, if you
where is that 1 arc minute referenced either from or to, please?
Between the plane you call horizontal, for example, and the actually horizontal plane at that point.
So there's 2 different planes, and that 1 arc minute is the difference between the horizontal plane and the horizontal plane. No.
Actually, yeah. Horizontal plane established at one point and horizontal plane established at another point.
Okay, so there's 2 different angular measurements of a horizontal plane, even at the point where you say the horizontal plane is the only point that it's there. So do we have an angular difference between horizontal planes, or do we have a horizontal only at a point? You seem very, very confused about what's going on here.
I'm not confused at all. But I say we cannot really reach mutual understanding.
No. Like, listen, we're telling you at the minute what a horizontal line/plane is. It's in a position. You're the one that refuses to believe that a horizontal can be anything beyond a point, even when it's stated it is a perpendicular through geometry. You don't even believe that as a definition.
No, I never said I don't believe that definition.
That's a straight line, then.
Accept that definition, then. If you're saying you do believe the definition, then you're not accepting the definition.
No, I accept that horizontal is perpendicular to vertical, except that is valid locally.
No, but you can't define what local is. So you need to drop that from your vocabulary and accept the standard definition.
Actually, local can depend on the context.
You haven't given us a citation for the local, even though you were asked to at the beginning of this conversation.
Okay, let me just search for that.
You just can't do that.
Because, the problem is that most places that define notions like vertical and horizontal assume that the reader is aware of the fact that the Earth is curved and that vertical directions in different points...
Sorry, what did you just say? They assume...
Actually, it is.
No, it's not.
Did you want to just have a quick look in that thing there?
It is, and it can be measured, and how it can be measured, I described in the first part.
I bet you'll like it.
Measured.
I bet you'll like it. Do you want to have a read of it?
Okay. Horizontal plane, a plane perpendicular to the direction of gravity, and plane tangent to the geoid or parallel to such a plane.
Yeah, go on.
I
Keep
wonder
going.
what.
Sounds good, doesn't it? Keep going.
Oh, so you agree about this part?
Keep going. I agree that it's wrote down there, yes. Carry on reading, please.
Surveying, a plane perpendicular to the plumb line within which or on which angles and distances are observed. For any planimetric survey, it is assumed that all plumb lines therein are parallel and all horizontal planes therein are parallel. Yes.
Oh, dear.
Yep. And that's actually not new to me. Because if you don't make
why have you just been fighting against it? That says that they're all assumed to be parallel. Yes, you've just been fighting along it. You had none of that. You said no way. They're not parallel. That was your opening line.
And the beginning of the sentence is quite important for any planimetric survey, and not all surveys will be planimetric. And I can bet you that, even though I'm not a surveyor.
Okay, so do you know what a planimetric survey is?
He's talking about lane vector.
I can guess. I won't say I'm 100% certain because, as I said, I'm not a surveyor, but I guess it's in the name. It's probably any survey that...
You see that line at the top as well? See what that says?
Okay, at the top. Horizontal line, a line perpendicular to the vertical, of course. And I don't.
So it's a line?
That. Yes, it is.
Yeah, so it's not but a point?
Yes, but it is at a point.
Yeah. And that...
Couple
that with the other one.
The horizontal line is a line.
Horizontal planes therein are parallel.
Yes.
Well, that would make it a horizontal line all the way along. Not just at that point. It would make it a horizontal line, a straight line.
But you know that for small
not just at a point.
It is enough to assume that everything is in a plane, for example.
Mm-hmm.
Basically, surveyors...
You've just been fighting against it instead of assuming it. Why did you do that? What was it that told you to fight against a horizontal being level? What was it?
Because in reality it is not. It's that simple.
Okay, so your understanding of reality is that level is not horizontal.
It is not, as a matter of fact.
Which you've never shown, never demonstrated, never proven.
Actually, indirectly, I have demonstrated it a few times. But
how's that? Can you show us?
I would have to translate these because those materials are in Polish. But yeah, indirectly, you can check that in a multitude of ways. Yes, indirectly.
So you've got no direct measurements?
No, not yet. But one of the methods of a direct measurement we talked about today, and as I mentioned, I intend to do that whenever I have the opportunity to.
Did you read the bit underneath? Might be a bit. I didn't highlight it. The bit that says horizontal refraction.
Yeah.
A natural error in
surveying,
which is the result of the horizontal bending of light rays between a target and an observing instrument. Usually caused by the differences in densities of the air along the path of the light rays resulting from temperature variations.
Yep, I know quite a bit about refraction.
How are you going to take care of refraction in your little observation?
So what we're doing is we're actually saying that the horizontal and the verticals are assumed parallel. Right, whenever we're doing any measurements and anything. But right after that, we're going to say that there is a natural error in our thing about light on the horizontal.
Of course, there is. It is small, but it is there. And it's sometimes important, sometimes it's not.
But you're doing the opposite, right?
What do you mean?
Well, you're assuming that there's a curve there, right?
No. Where did I assume there's a curve?
The water level, right? The water level curves. You said that.
Okay, yeah. When we were talking about the water levels, then yes. But I don't need to assume a curve when measuring the whether the vertical lines are parallel.
Okay, so the water level would be assumed horizontal, would it?
No, not really. Well, it would be assumed horizontal in planimetric survey, for example.
Yeah, like if you were building a canal and you didn't want the water to fall out of it, which way do you think you would attempt to survey that, right? If you were a surveyor, right, how would you survey the level of the canal? You don't want the water running out. You'd be awfully embarrassed if it was your job.
To be honest, I don't know, because I have no idea how surveyors work exactly.
Oh, do you imagine there's some different sorts of surveyors?
But anyway, what I would like to
do
point
you
out,
imagine there are different surveyors? Because that one there says like planar surveyors that use horizontals.
planimetric survey. Survey, not surveyor. So
yeah,
any surveyor could make a planimetric survey. Or
yeah, I don't make a difference between any surveyors. They all do the same job. They all measure reality.
Use the same tools.
Yeah.
But yeah, I'm perfectly sure that there are surveys that are not planimetric.
Oh, what would they use then?
I would guess that they would probably use the approximation of a sphere or an ellipsoid or a geoid, depending
Any
on the
idea
level
what
of
tools
detail.
they'd use?
Sorry?
Any idea what tools they would use? Could they use, for instance, an auto level that it just establishes a horizontal?
Probably, but as far as I know, and
So
I've actually asked the surveyor about this.
How would you get the curve from a tool that only measures from point distances, right? And it basically measures right angles, right? Vertical, height, horizontal. How would you get a curvature from that?
Well, you would need to have something that you know is level, and then measure if this actually.
Yeah, that's what the tool is. The tool is the horizontal, right? That is your level.
Yeah.
The tool called level.
And you're confusing level and horizontal again, and that's no wonder, because you think they are the same, but they are not.
Okay, so what is a tool that establishes a level, and what is a tool that establishes a horizontal? Is that the difference what you imagine when the surveyors go? Do surveyors use the ones that are measuring the curvature? Do they use a level? And the surveyors that are doing the plane surveying, do they use it's called a level as well, isn't it?
I'm pretty sure they use equipment such as tachymeters or auto levels or theodolites or whatever,
Levels.
what have you.
Auto level.
But
that's horizontal, though.
But on larger scales, they just take explicit corrections for curvature and for refraction. So
explicit calculation.
They make
with explicit correction.
Yeah, they change a calculation after they do a measurement.
Yes.
Yeah.
Because otherwise they would get incorrect results.
What? Sorry, say that again. They do it. They take a measurement, then they have to do a calculation to that measurement. Otherwise, it won't be correct when they took the measurement.
Kinda, yeah, because
so you get can you go and measure that piece of wood? Oh yeah. Okay. And then I come back. It's 5'4", right? I'll have to do a calculation. It's 5'5".
Almost. Except that's for larger scales. So, for example, if you want to, let's say, you want to measure elevation of some points that are separated by a kilometer or more.
Yeah.
Then So then I'm not sure how surveyors do this exactly, but if they were just to use a theodolite or I don't know what it's called in English, but I guess auto level is another thing that could be used here.
Yeah.
Then probably one surveyor would be at one point holding something with a scale or something like that.
Yeah.
And the other surveyor would be sighting this from another point, right?
Yeah, measuring
and now
rod. Measuring rod
exactly.
and auto level, yeah.
Okay, yeah, exactly. So now if they are a kilometer or more apart, and they just wanted to take the result as the difference in height between in elevation between those 2 points, they would make an error caused by the
they would
curvature
make
and
a massive
refraction.
error by trying to measure over a kilometer.
Yeah.
Yeah, that would be a big mistake. They should have used differential leveling techniques, shouldn't they?
Probably.
Yeah.
As I said, I'm not a surveyor, so they probably had
we
some
can
clever
tell.
techniques.
We can tell.
Yeah.
So for you to speak like this about something you don't really know about, why is that?
Why is that?
Yeah, why is it that you think you can come in here and talk to us about something that you don't know anything about and freely admit that you don't know anything about it?
Well, actually, I didn't bring up this topic.
And yet you think you've got an authority on this
No.
topic that you know nothing about.
No, I don't think I have an authority on
So
surveying.
you've told Bev he's wrong on many, many occasions this evening. So
because
you
in
are
some things he is wrong as a matter of fact.
that you have an authority over him in a subject you know nothing about.
No, not really, because
yes,
I never.
This is exactly what's happened.
Nope, because
Yes.
the things that I've said he was wrong about weren't directly connected to surveying,
What,
but they were
horizontal
also.
and level being a plane.
Well, yeah, they are also quite tightly connected to pure physics of things
It's
like
not physics, is it? It's geometry.
geometry applied to physics. Well, vertical direction
the fluid
is
dynamics of water. You've told Bev that he's wrong about the fluid dynamics of water. When
That's also
you haven't
physics.
actually proven otherwise. You haven't shown or demonstrated otherwise.
No, but I've said what are the methods that you could check for yourself. You don't have to trust me, and
we don't trust you.
me.
Believe us,
Yeah.
we don't trust you. We
Yeah,
don't
sure.
trust Jeff. We don't trust anybody.
I have no problem with that, but have you actually tried using any of these methods to check for yourself?
At water level, yes.
No, not the water level.
Why
Because
would
the
we?
water level won't
Why would
actually-
we want to use anything other than the water level and establish a horizontal plane using surveying equipment? In
Yeah,
actual fact,
because-
yes, we have used other methods. We have
Because the water
established
level
a
won't show
horizontal
you anything.
plane with surveying equipment.
Okay.
If you were doing a test and you wanted to do a test for something, right? And you want to do it as cheap as possible, and all you're trying to do is establish a horizontal, right? And check it. What would you use? I mean, I know you said you've got that tachymeter, but that's not horizontal, right? Because the initial thing was, I'm here because somebody said to me, when I said level is a straight line on a horizontal plane, they told me I was a child abuser. So I'm just out to prove that level is a straight line on a horizontal plane. I mean, I've already proved it to myself.
Okay.
So
Well,
in order to find out if level is a straight line on a horizontal plane, we have to use the tool in the most cheapest way. Now, you say, because we need to establish level being a horizontal line and a straight line, it's pretty obvious that horizontal's a straight line. You're not going to disagree with that, are you? So the only bone of contention here is level the same or different than horizontal? Now, we have tools to establish a horizontal. We have a problem here, though, because them tools are called levels. Now, you're the one that wants to separate them two, whereas one of them is the tool and the other one is horizontal. Now, I'd say level is just the practical use of the word horizontal. But you say I'm wrong and you have a different way of doing that. What we do is we establish that have you heard our logic? Are you any good at logic?
I would say so.
In order to simplify things, right down to the basic facts, we say if Earth is a spherical object, P. Are you okay with that?
Mm-hmm. Yeah, I think you actually said that the last time we discussed.
Well, I like to say it loads. If the Earth is a spherical object, P, then the surface of liquid water must curve.
Yes.
Yes.
I can agree with that.
Q. But then I would give you the fact that a water level is a tool to establish a horizontal plane of reference.
Yeah, and up to some precision, sure.
Well, a horizontal plane within mathematics is a two-dimensional flat surface that extends indefinitely. Now, where is your
pure mathematics with practical application, and that is never a good thing.
Well,
because, sure.
It's not the practical. It's the name of the tool is to establish a horizontal plane of reference.
Sure.
Now,
but this is a practical application, right?
Okay,
and
so that what
practice,
do they not mean?
Hmm?
What is it within that statement that they don't mean, that you're telling them, right? And it's practically used by people. Anything. Okay. So when you say a margin of error, what do you mean by a margin of error?
I mean that nothing that you can do in reality is perfectly accurate.
Okay.
And so everything that you do in practice will be always, well, how do you say it? Well, we'll always have some margin of error, right?
Okay. So let's go a mile in between our ends of the water level. How much margin of error from the horizontal plane of reference will at both of the ends of that water level have?
Well,
because you notice it says horizontal plane.
Yeah, sure.
Right, just one plane, not two. Yeah. Just the one plane.
Yeah, because 2 points will establish a line, actually, not a plane, but yeah.
But because it's a water level,
it will be.
You can move that other one all the way around it, and it would be a plane, right? That's
sure. Yeah, okay, and that not exactly, but yeah. Anyway.
What? No, not exactly, but yeah.
Oh dear. You get yourself in such a pickle, don't you?
Yeah, if you move one end around the other, then you won't get actually a plane, but something more similar to a cone than a plane. But
no, that's not horizontal.
Yeah,
that's a tilt. That's a tilt away from horizontal. Right? Because the only frame of reference you have is that horizontal.
Anyway. If you use the water level, you will get something that is horizontal within 1 arc minute. Well, if you use the water level over 1 mile,
just ask a question.
What?
Sorry, can you repeat the question?
I don't know. Did he cut out?
Yeah. Maybe you clipped out, but I'm sure he overspoke a question you asked.
Oh, sorry.
Oh, for me?
You asked the question. Yeah.
I can't remember what it was.
Yeah.
I was in mid-flow.
You might need to.
Let me just jump out. Is that better?
Anyway, I'll need to leave in around 10 minutes, let's say. Okay. So, yeah. Just putting that out there.
So, you said within an arc minute. Now, let's extend the water level to 2 miles.
Yep.
What
and now
is
you
that?
Have precision up to 2 arc minutes.
2 arc minutes, right? See, that only sounded like that just doubled, right?
Yep.
You do have an exponential figure for your model, though, right? Did you forget about that?
Not exponential. You mean quadratic, probably, right?
Well, you know what I mean.
Yeah, you mean the smile squared stuff in the expression for curvature, right?
there's a function that makes it increase at a exponential rate, right?
Yeah, except that's an expression for the drop, so basically for the difference between.
Yeah, but that's what we've got. We've got a water level. We've got a water level. Right?
Because now we are talking about angles, and the angles.
No. You were talking about angles.
Okay.
We're still talking about the water
angles.
level. And the drop, because you just had a conical surface. Now, if you extend that water level, would that get more conical on your model?
Yes.
Because I'm imagining your model. That's not horizontal, is it?
No, at some point it's definitely not horizontal.
At what point does a water level...
on the accuracy that you need.
Okay, right. Now, in the description of a water level, have you looked at it? Yeah. Do you see the bit? The water level at each end of the tube will be at the same elevation, right? Whether the two ends are adjacent or apart, right?
And I never
water levels have been used for many years. It's really old tech, right? Yeah, the water level is lower tech than the laser level, but it can be more accurate over long distances. And works without a sight line, right? It can be more accurate. More accurate at what?
Yeah,
more accurate at being and establishing a horizontal
at establishing a level
plane of no. Look, a water level is any device utilizing the surface of liquid water to establish a horizontal plane of reference. Horizontal plane of reference, not level.
Yeah.
It is a level, a water level device.
Because up to some accuracy, this can be treated the same, but only up to some accuracy.
What accuracy? Because it's not mentioned in here. In fact, it says more accurate over long distance. So its accuracy increases over long distances.
Probably
which
at
is
some point.
in exact opposition to what you needed to do.
I'm aware of it. Because I'm pretty sure that the long distances mentioned here were not long distances of the order of a mile or 2 miles. Or
how do you know that?
Because
is it one of your magic assumptions?
Yeah.
No, that's basically what's implied by physics.
Your surveying experience has taught you that.
No, just physics, pure physics.
Which physics would that be?
Well, the physics that you can learn at school, for example.
Which physics would that be?
It will be very accurate at establishing the points that are at the same elevation. It will be less accurate at establishing a level. Horizontal direction.
It will be more, level. So the only problem you have with it, even though it says the water level at each end will be the same elevation, right? Because notice it says at the same, at each end as well.
Yes.
Doesn't mention anything about in the middle.
They didn't think about putting one in the middle.
No, why? If it was the same elevation at each end, would it be the same elevation in the middle?
Sure.
Right. So the only bit of this water level thing that you have a problem with, is the fact that it establishes a horizontal plane of reference.
Yeah, and even that is correct if you take into account the fact that it's an approximation.
Really good job that we're doing a test to establish whether this water level actually establishes a horizontal plane of reference. Now, what would you say if, just like this thing says here, that a water level establishes a horizontal plane of reference, what would you say if you were to find out that level did indeed mean horizontal?
What do you mean?
What do you think it would mean?
Wait, but
what would it mean to you if you were to find out that all of these references that we keep giving you, and even the surveyors that you don't know anything about, they use horizontal reference frames in order to establish elevation changes on the vertical, right? What would you do if you were to find out that the level that they used was a tool to establish a horizontal plane of reference.
In other words, what would happen if we're right and you are wrong?
Oh, don't say that.
Well,
make it a right and
Yeah,
wrong
if
thing.
you were right and I was wrong, I would probably have to accept that.
Okay.
That's the point. But so far, I'm afraid nothing points me in that direction.
Okay. But all we would have to prove, really, to you, is that level is horizontal, right?
Yeah, probably, but not on the basis of definition, but rather define those notions and then prove in reality that they tend to be the same. Yeah.
Okay. So, if we were to ask a surveyor, what would you say to that?
If I could also ask the surveyor some questions, sure.
Okay, so what would be the questions? Because, I mean, we can write these down, or everybody here will be able to remember them. What would be the questions that we should ask a surveyor about level and horizontal?
Okay, so what I would ask it would be, if you establish a horizontal plane of reference at some point, will it be the same as the plane as a horizontal plane of reference established at a different point?
Okay, so
Horizontal plane.
yeah, could you
is a
establish
horizontal
that
plane.
horizontal from one place to another? Could you take
Extend?
is that a horizontal point at one point and move that to another point to make it on the same horizontal? Would that
That's not what I
sound?
said.
I'm just trying to work out how you'd ask a surveyor that question.
Exactly the way I phrase it right
Go
now.
on, say it again.
It's
then.
gone again. Yeah.
Okay. If you establish a horizontal plane of reference at one point, will it be the same as a horizontal plane of reference established at another point?
Right, hang on a minute, Bev. Why don't we just establish a horizontal plane, or sorry, a horizontal point?
I'm just
is
thinking,
what
like,
you
if
need.
it's a
Horizontal
centimetre
plane,
higher,
I said.
right?
And extend it.
Yeah, but see, if you move your auto leveler, which I think is what he's saying, and you don't put it at exactly the same height, then it will be a horizontal plane, but it won't be on the same horizontal plane, right?
Okay.
If you understand what I mean.
Okay,
Yeah,
so you
yeah,
could
yeah.
ask it differently. If you
Okay.
establish a horizontal plane of reference at a point, will it be parallel to a horizontal plane of reference established at another point?
Okay. So is the are the horizontals parallel? Would that?
Basically, yep.
Yeah. Okay. So would that be like when you're doing your transitions? Because you do know how they do differential leveling, right? You sight a point, you sight a back sight, and then you sight a foresight. Then you pick your level up and you move it, and then sight your old foresight as a back sight, right? So, are you asking whether the horizontal planes from each of the transitions, or when a surveyor does his job, are they all parallel? Is that what you're asking?
Yeah, I think you could phrase it like that, yeah.
Could we say assumed? Like that little bit that you read out earlier? Or would you say that should we get confirmation that they're not only assumed horizontal, but they are practically horizontal?
Yeah.
Yeah.
Yep.
Okay, that's a good one.
So
Because as
you
actually
basically you're
also,
asking the surveyor if they know how to do their job.
Yes. Yeah,
Okay,
it may
maybe.
sound a little bit demeaning, right? But I mean, if
I
that's
reckon.
what these people are asking us, right?
Because surveyors, that's what surveyors do.
Yeah.
No?
But that's what we're saying.
establish horizontal planes.
Okay.
Yeah. Have you
So
ever
want
ever
us-
talked
hang
to
on,
anyone?
Bev. You want us to ask a surveyor if they know how to do their job?
yeah, not exactly in these words.
No, that is exactly what you're asking us to do.
Have you
If you
ever
prefer,
done that
but-
to anyone? Have you ever called any surveyors and asked them that yourself?
Bearing in mind that you know nothing about surveying.
Not really.
Yeah.
But On the other hand, if I was doing the asking myself, I could also provide some context.
Have you ever asked anyone?
I have actually asked the surveyor about one thing.
Okay.
Did you ask him if he knows how to do his job?
Did you ask him
No,
if
not
he
really.
does horizontal planes are parallel?
No, I was actually asking him about the spherical axis in triangles.
Oh, right. Yeah, brilliant. We could go to that, but wait, is there any other questions we could ask? Or maybe we can get onto a triangle question with surveyors, right?
I think if we ask a surveyor if they know how to do their job, they're going to hang the fuck up on us. But so that would be the end of the conversation.
It'd be nice for him to do that, actually. I mean, that'd be something. Yeah. I mean, we do ask questions, but we don't ask questions like that.
No,
that would be really demeaning to a surveyor to ask him questions like that.
Absolutely.
It'd be like going to an accountant and ask him and just if they can add 2 and 4.
Can they use a calculator?
Just check that you know what maths is.
Yeah. Or asking
on the other hand, you have no trouble.
Surveyor if he knows what the.
Yeah. On the other hand, you have no trouble asking a physicist if they know what happens to water in the water level, for example.
Okay.
Yeah, no, I don't.
Equipotential, right?
I have no clue.
If you didn't have this predetermined belief of the ball, you wouldn't be asking any of these questions. You would just be like, yeah, they established horizontal. That's easy. Bam, done. But no, now you're trying to justify the fact that how do we have this horizontal that follows the horizontal of the Earth, but the Earth isn't flat? Like, then you start getting into cognitive dissonance. So don't worry about that, man.
Is what he gets into.
Just go to the horizontal. You're really going to ask? You're saying we can send a thing to the moon and land it and have it back up, but if we can't establish a fucking horizontal? What are you, retarded, man? Come on.
Okay, but as I said 10 minutes before, I will have to leave.
Okay.
So,
when are you going? Can we just do this quick triangle thing really quick? Because you said you talked to a surveyor about.
Quick, but we can take a note of that and we can talk about it another time.
Brilliant.
Because it's quite late and
yeah.
I'm an hour ahead of you guys, so I will be going to sleep.
Yeah. Well, thanks for popping back round. It's been productive.
Yeah. Are you going to do your experiment before you come again, or
we'll see.
You experiment test?
Why does he get an experiment? Why do the ballers always get experiments?
Yeah,
we just have to do with tests.
That's what it is.
QE will be coming round ranting if we talk about an experiment.
I'd love to do the test, if you will, as soon as possible. But I have no idea when I will have the opportunity.
So will you be back before you do it? Do you think?
Oh yeah. Of course you will.
Yeah,
probably. I would guess so.
Yeah,
because it will take some time. Yeah.
Okay.
Anyway, thanks for the conversation.
Okay.
Yeah, thank you.
Thank you very much.
Okay. Yep. See you another time.
See you later.
Bye.
We're going over McToon's tomorrow, aren't we? So, do you want to start doing a bit of promo stuff?
You're going back to McToon?
No. We are going over the McToon.
Oh, okay.
I hesitate to call it a debate.
No, it was
debacle.
It was an embarrassment
We're going over that tomorrow, so we can have everyone come round.
Jeff couldn't run away quick enough. Yeah, so if you're around tomorrow, Emma UK Discord, pop in.
Yeah, come and listen to like acclaimed. Right, I don't like saying the word. Jeff. Jeff was on the debate with us.
Briefly.
Well, yeah. Until it got challenging. I think it was about the time we laid a hose pipe down next to a horizontal line that we'd established,
which was adjacent to a body of water.
But as you've noticed tonight, they've lost that line. The lines had to go. Horizontal can no longer be a line. This is in preparation. I'll give you it's preparation for bendizontal.
This is just getting, the deeper we get into this, it's just getting more and more crazy from them.
Well, it does. I mean, this was the point we started at. You start at something simple, and then make it simple, and they end up not understanding what a straight line is.
Yeah, or a plane,
Yeah.
horizontal plane. I mean, all the buildings in Chicago are built with a mathematical deviation.
It's supposed to be an ambush. I think that's what he was trying to do.
What?
Like he wanted to ambush you into thinking that he could have some sort of surveyor who'd be able to talk circles around you. Because I don't think, did he tell you what the whole like shtick was going to be? Or he just, it sounded like at the very beginning he sent you a link to click and then didn't say shit else.
Yeah, he gave me a Zoom thing. We'll go over the McToon stuff tomorrow.
Oh, the McToon thing. I thought you was talking about tonight.
Yeah.
Oh no, I'm sorry. Yeah, I probably could have
tonight has
added
been
some context.
This last one was live, I guess, if anybody's watching it now.
Yeah, there was.
There was another one before.
Yeah.
Well, it was still live.
Evening, everybody on YouTube. How are you doing? Give us a one.
Yeah, that one beforehand though, that we weren't actually live. Now that was a completely different conversation. It was very nice. I'll be putting that one out tomorrow or something. But I really like that. I think he came back as well, didn't he?
Yeah, he did. He was
listening to it for a bit, but obviously didn't want to speak up otherwise. Because he was finding out the opposition.
Yeah, I mean, he was all about the geometry as well. So if he should have been able to jump in on that conversation and have some input, but you know, some people are new to Discord and they don't like to do that.
Yeah, it's been a good night tonight, and if people are listening, then good. We're going to be doing a fair bit more of this, and like I say, going live tomorrow, and hopefully we're going to go live on quite a few channels. We'll try and get this out.
And don't forget the website.
On the level.live now, live as a website. DP merch. You can get all the DP merch you want. T-shirts.
Yep. Click over there, T-shirts, hoodies, you name it. And don't forget all that stuff. Any money raised is going to help fund future tests, experiments, observations, however you want to phrase it. It is going to help us with financing future endeavours, should we say.
Yeah, well, I've got a few more things up my sleeve, but we've got to get this one established first. Mm-hmm. If we can't start off with a like I say, a level base, so everybody knows what it's all about. You can only build from that base. Thanks, Cleary. You're like, how did you do that? We've got to start off with a base of understanding, and then we go from there.
Yeah, I've been telling Emma it's all about the base for ages.
Yeah.
she just will not listen to me.
She's had to go.
Yeah. Cool.
I wanted to see Paige as well, because Paige did a fantastic thing the other day on Ranties. I'm calling it Paige's proof. But I don't really want to let it go until Paige is here.
Wait till she's here. Yeah.
It has been on the board all night, and I've had to leave it there. So Paige, if you're listening at any point, pop over. We've got work that one out, and that's thanks to you. So Paige's proof. Be absolutely able to destroy Rumpus anytime he gets one of his stupid drawings out. And what else were we going to do tomorrow? Tomorrow, get as many people around here as possible. Multiple live streaming. If you want to come and also live stream it, come and join in. We're going to be going over the tactics of the, I don't know what to call them, the globe model lovers that just want to demean people in order to gain profit.
They have no argument, and they are standing in the way, basically.
Yeah, they are
the money of gullible
anti-learning.
people. Yeah, absolutely.
If you try and make a point, they will purposely stifle it, and they will use multiple tactics in order to do that. And that's the sort of stuff we're going to be exposing tomorrow. Should be useful information.
Super chat money out of gullible people.
Yeah.
So sad.
Yeah, see, these people that take money from them, we'll have to go over this tomorrow as well, but the people that take money from them, so one of them can say something really nasty to someone else, they'll take that money and then say, well, that was not me though, I was just taking it, it's a super chat. They'll take that money off them people, and those people are willing to pay that money for them to say that to us. They could just come here. They could come here and have a conversation with us.
And it'd be free.
Yeah, and if they were brave enough to say those things, they could come here and say it. But they would have to be forced into it, the argument.
They also fit the bill for shills, because they are actually shilling.
Yeah. Yeah, they're taking money to propagate some sort of deception plan, right? Because it's not real. They're taking money to say things like, for instance, I have to keep going back to it, but I mean, I'm not a flat earther. I say that to them. I am not a flat earther. Yet they were taking money off people to say, yeah, Bev's a flat earther. Means nothing.
They're not challenging.
Yeah.
Then not even challenging his audience. Said, "Oh yeah, thank you for the super chat, but Bev is not a flat earther." He'll just keep saying, he'll double down on it.
Yeah,
they got this moral relativism. Whatever they believe, they can believe or not believe things, and that makes it reality. It's like this really subjective atheism that has to do with bending and shaping reality to conform to what they want it to be at any given time.
What they need. Right then, everybody. See you all tomorrow.
Good night.
Bye.
Yeah. We'll call it a night then, yeah? Are we going for the recordings now? Tomorrow, I don't know what time tomorrow. The weather will probably be bad, so it may be full day job. You never know.
You never can tell.
Keep an eye out. See you tomorrow.